this is a problem on number 8. What's kind of interesting about this is there's a rule that you have to use. And let's just kind of go over this. So if I just take a look at the x to the 4th, it's raised to the 2 power and then raised to the 4 power. What I want to do is use the rule of powers raised to a power. Now when a power is raised to a power, that means you multiply the exponent. So this would be 4 times 2. That would give me 4 times 2 right here, and that would give me x to the 4th now raised to the 8th. And then now when I apply that power rule again, that becomes x to the 4 times 8, which would be x to the 32nd. Now down here is a little bit different. Now that rule will also apply to 4 times 2 is 8 times 2 would be 16 on the y. Okay. Now this down here is a little bit different. Remember there's a 1 on that 3, so that would be 4 times 1 would be 4, and then 4 times x to the 3rd, so 4 times 3 would be the 12. So that's just a little bit of a run through. Now let's go ahead and let me go ahead and redo this problem. Try to slow down a little bit. So let me rewrite it. So I've got x to the 4th, y squared, looks like a z, change that, all raised to the square, and then that is all raised to the 4th power. Then it's 3 to the 1st, x to the 3rd. So 4 times that 2, that will give me x to the 4th, y squared, all raised to the 8th. This down here will be 4 times that 1 would give me 3 to the 4th power. 4 times that 3 would give me x to the 12th. Now, are you okay with that so far? Let me move this over. Now we have to take care of the parentheses here. Close those brushes. So 8 times 4, that would be x to the 32nd. 8 times 2 would be y to the 16th, divided by, I don't do anything with this 8 down here. This is all done. That 8 only applies onto the parentheses. So this would be 3 to the 4th and x to the 12th. Let's go ahead and move this up a little bit. You still see that okay? So now what I have to do is simplify this. Now let's take a look at the division property here. I've got x to the 32 divided by x to the 12th. Now I'm going to rewrite this. So what we're going to do is we're going to take x to the 32nd and we're going to change x to the 32nd to x to the 20th times x to the 12th. Does that make sense what I've done there? Because 20 plus 12, multiplying like bases, that would equal 32. Now do you see that that x to the 12th cancels? So now what I've taught you to do is this. If you look at the two exponents, you're dividing like bases, and you look at the two exponents, you take the lower of the two exponents, subtract it from the bigger. So basically what I would do is take 32 subtract 12, and that would give me x to the 20th. Now do you see how that works on top? Isn't this the same as 1? X to the 12th divided by x to the 12th is the same as 1. So that's why I end up with x to the 20th. Now there's nothing that's done with the y to the 16th, so it just stays y to the 16th. And then 3 to the 4th can stay as 3 to the 4th, or 3 multiplied together 4 times would be 81. Okay, so you follow me on this, people? So now what I end up finally getting is that would be fine for an answer, or you could use x to the 20th, y to the 16th over 3 to the 81st. So that answer would be okay, and that answer would be okay. Okay, another problem that I was asked to do was number 10, and it says simplify in parentheses a -2 raised to the -8 and simplify a -2 raised to the 8th. Use -2 as the base, write the exponents using a positive integer. And if your answers are different, please explain why or why not. So let's go ahead and we're going to take 2 to the -2 in parentheses raised to the -8 and a -2 raised to the -8. And let me go ahead and close this window. Give me something to write on here. So I've got a -2 in parentheses raised to the -8, and just to review the rule that we've got here, remember if I have a to the -n, so a is the base, -n is the exponent, is a negative exponent, so you can see that that's what we have here. What I like to do is write something with a denominator. We know that everything has a denominator, and the way this rule applies is all exponents have to be written in the positive, so we do not want any negative exponents. So what I do to make this base the exponent positive on the base is I take this entire numerator, I move it across the division bar. That numerator now becomes the denominator, and then that exponent becomes positive, and then there's at least always a 1 for the numerator. So if I apply that to the quantity of a -2 raised to the -8, this is what I have. Remember, there's a denominator of 1. So I'm going to rewrite this with the parentheses, and then what changes on the exponent? It changes to a positive 1. Now if I take a -8 and I multiply it, or -2 and I multiply it together an even amount of times, and we're just going to go ahead and walk this out. So there's 1, 2, 3, 4. That would give me a positive number, because a negative times a negative is a positive, and negative times a negative is a positive, and then a positive times a positive would be a positive. So this turns out to be a positive, I think it's a positive 64. Let's check it. Let me give me a calculator and we'll go ahead and make sure that this is right. No, I think it's bigger than that. So let's take, in parentheses, a -2 raised to the 8. That gives me 256. So this becomes 1 over 256. Now you either can have that for an answer or that for an answer on the simplification for this one. Okay, now let's do the other one. I've got a -2 raised to the -8. That's over 1. Now let's apply this rule. I have to write all exponents in the positive. This base goes, the numerator goes to the denominator. This base with an exponent comes down and it changes sign. Remember, there's a numerator of 1 on the top. And now when I type this in my calculator, let's see what happens. So I don't have the x, I don't have the parentheses this time. Look what I get. I get a -256. Well, why is this negative? Well, let me tell you why. There's a -1 times 2 to the 8th power. That power of 8 does not operate on the -1. It only operates on the 2. This one up here, where you have a -1 times 2 raised to the 8th power, you have a -1 times itself 8 times, which will make it positive, and the 2 to the 8th power will make the 256. So that's the difference. So the reason why your first answer is positive and your second answer is negative is because that power on the 2 does not operate on the -1. Okay, that's your answer to number 10. Okay, the next problem that we need to do is number 11, and then we'll do number 12. Alright, so now the best thing to do on this one is let's just look at the numbers first. Now, one thing that I ask you to do is to apply the associative property, where you can kind of break this stuff into 3 smaller problems. We finish writing this down. So there's problem number 1, problem number 2, problem number 3, and then when we get all that done, then we'll put it back together for one answer. A lot of you left this as 2/6, and the reason why you missed it, you didn't simplify it. And we talked about that, so you know that one's on you. So now I know that has to be a 1/3. And now x to the 3rd over x to the 6th. Let's take another look at this. X to the 6th can be written as x to the 3rd times x to the 3rd. And do you see that this right here, that's the same as 1? So what I end up with is just an x to the 3rd on the bottom. And remember, there's always a 1 when you need it. Now the other way that I taught this is I take x to the 3rd over x to the 6th. You have like bases, so what you want to do is look at the exponents on the numerator and the denominator. Because of the denominator is bigger than the numerator, you're going to subtract the exponent of the numerator, and what do I get? 3. So 6 minus 3 gives me 3, and so that x to the 3rd stays on the bottom. Now let's take a look at the y to the 5th over y to the 4th. Let's use this idea here. 5 is bigger than 4, so 5 minus 4 gives me 1, so that means I will have y to the 1st on top. So my final answer would be y. You could put y to the 1st if you wanted to. You could leave the 1 there if you wanted to. So 1y times 3x to the 3rd would be fine. Or you could put y over 3x to the 3rd. And that's your final answer, number 11. Okay, let's move on to 12. So our next problem is 8 over 24 c to the 3rd over c to the negative 3rd g to the negative 2 over g to the positive 8. Let me move this over here so I can give myself a little bit more room. Now what we want to do is to break this into pieces. So I've got 8 over 24. That's going to change to 1/3, right? Then I have c to the 3rd over c to the negative 3. Well, this thing has to move up top, doesn't it? Because I need to write this exponent as a positive. So if I move that up top, it's going to go away, and I'm going to have c to the 3rd on top. So that'll give me c to the 3rd times c to the 3rd will give me c to the 6th. And remember, there's always a 1 wherever you need it. Now let's look at g to the negative 2 over g to the 8th. Well, this g to the negative 2, this negative 2 has to be positive, so it's going to come down to the denominator. So g to the positive 2, g to the 8th times g to the positive 2 gives me g to the 10th. And then remember, we always have a 1 when we need it. So my final answer, what's my numerator? I could have 1c to the 6th, that would be okay. And then 3 on the bottom, right? There's times of 1 times g to the 10th. So your answer would be 1c to the 6th divided by 3g to the 10th, or you could write it c to the 6th over 3g to the 10th. So either one of those answers on number 12 would be correct. Well, thank you. Hopefully that will help you with those last 4 problems. And if you understand these last 4, some of the easier problems like 1 through 6 and 9, which some people missed, you should be able to get those right now.